All right, so let's take a look at the upcoming homework. So most of these are pretty easy, just describing the correlation coefficient, making sure you understand what that means, what it represents. I think, honestly, I should add in some extra homework here. I'm not sure you get enough practice. I think I mentioned this in the other Zoom meeting, but if I don't know what's going on with this problem. I didn't write this question, but this makes no physical sense to me, where we've got time and mass, and we're trying to imply that one of them depends on the other. That makes no sense whatsoever. Mass would never depend on time. Like, mass is a conserved quantity. We don't lose mass. So this question makes no physical sense. But when you're going to draw your dot plot here, anytime time is one of your variables, that will be your independent, or we call the explanatory variable. And then mass here would be your response variable. So these would be your x's, these would be your y's. I want to do this problem, I think it was. Yeah. And I'm going to show you a couple of different ways to do this problem. Okay, so I've copied it over here. First thing we want to do is do linear regression on it. So if we're going to do this in our calculator, first thing we got to do is make sure our calculator has diagnostic on. When you sit down to take the midterm, they're going to reset your calculator. And you're going to have to turn this back on. Make sure that's on your formula sheet. Make sure to remind yourself to turn diagnostic on back on. So that on, like, I'm going to turn it on right now, and then it's good. I never have to do it again unless I reset my calculator. So you don't have to do this for every problem. You only have to do it if you reset your calculator. So we're going to hit second here. I'll start from the beginning. Second 0 to get to catalog. And we're going to scroll down. You scroll for a while to diagnostic on, not there, that's off, on, until it says done. Keep hitting enter until you see done. I don't know why this isn't the default. It should be, but it's not. So once you turn that on, it's on now. Okay, then we got to decide out of these variables, which would be our explanatory variable, which would be our response. Who's our x and who's our y? Anytime time is one of your variables, that's your x. So these will be my x's, these will be my y's. So I'm going to enter those in the calculator. I'm going to hit stat, into edit, so enter. And you can see I've already typed them in, so you don't have to sit and watch me type these. I typed all the times into L1, all the distances into L2. Okay, then I'm going to get out of there. Make sure these are the same length. If one of these lists is longer than the other, it's going to yell at you. Again, if you need to clear a list, maybe you've got stuff in L1, you would go up to the top and highlight L1 or whichever list, hit clear, and then hit enter. And that'll clear the list. Okay, now that I've got those in there, I'm going to hit stat, over to calculate, so I hit over, and down to number 8. That's the button we're going to use. I may have mentioned this before. We could also use button 4, and it'll give us the same information, just in a different order. But we're going to use number 8. Make sure those are the lists we used. That's what I used. X's were in L1, Y was in L2. Leave everything else blank and hit calculate. If your screen looks different, some of the older calculators, you won't see all that. You'll just have a cursor blinking. It'll say linear regression, and the cursor's blinking, and it's waiting for you to type something. What you would type would be L1. See, he's right there. Let me start over. You would hit second 1 to get L1, comma, second 2 to get L2. So your screen would say linear regression, L1, comma, L2. You would close your parentheses and hit enter. Clearly, like if I do it now, that's not going to work here. Make sure you know how to do this on your calculator, because that's all you'll have for the midterm. All right, let me go back and do my linear regression again. Whatever your calculator looks like, this is what you should have on your screen when you're done. Okay, now we got to figure out what we've got. So it's spitting out our linear regression in this form. So the number beside X is the slope. B is going to be my slope. A is going to be the Y coordinate of my Y-intercept. Now, they told us here not to use X and Y, but to use D and T. So see how they wrote it out? T is playing the role of X, and D for distance is playing the role of Y. Now, I could have written this in the other order. I could have typed 0.41 plus 8.45 T, same thing. Because that's how the calculator spits it out here, same thing. But that is the slope. I know that because it's the number beside X. And that's the Y coordinate of the Y-intercept. Now, let's interpret those. What does that slope mean? Slope is always change in Y per change in X. For each additional X, what's X measured in? Hours. For each additional hour, Gary is going to change his distance by 8 miles. Slope is always a ratio with change in Y for each additional X. So that's how we would interpret that. For every hour, Gary goes about 8.45 miles. What about the Y-intercept? The Y-intercept is 0, comma, A. So there we would say the model predicts at time 0, Gary was a distance of 0.4 miles from his starting point. Clearly, that doesn't make any sense. Gary was 0 miles from his starting point. Like, that's what we mean by starting point. The Y-intercept a lot of times is going to be something silly, and we're okay with that. Like, these models are only meant to make predictions around the data we already have. If I were to draw in a line here, that Y-intercept is not going to necessarily mean anything in the real world. Okay, then they ask us to make a prediction. They give us a time. I have a model. Here's my model. That's a time. I literally just plug it in. So like that would be 8.45 times 1.25 plus 0.41. So that's about 11 miles. They rounded up a little bit because it said to the nearest 1/10 of a mile. Okay, what about the correlation? Here's my correlation coefficient, 0.98. That means we have a very strong positive correlation. Why did I say strong? Because it's close to 1. Why did I say positive? Because it's positive. Like, look at the number. It's a positive number. It's a strong positive correlation. And plus, I can look at the graph. Look, it's going up. The dots are going up as I go from left to right. It's a positive correlation. I can also look at the slope. The slope is a positive number. Everything here says positive. Okay, and then the question didn't ask for it. But how would we interpret r squared here? R squared, like, make sure you write this down. You might have a question on the midterm about this. R squared is the percentage of variability in Y accounted for by the model. Who's playing the role of Y here? Miles. So if I were to interpret R squared here, I would say 96%. I just turned R squared into a percentage of the variability in the miles traveled is accounted for by the model. It's always the same sentence. The only things you got to fill in are this number right here that I get right there. Just turn that into a percentage. And then these words right here are whatever units you have for Y. Okay, let me show you another way to do this one that I think you'll use more often in the real world. These calculators are great. Like, I love my TI calculator, but they're not going to draw a graph for me that I can print out. Excel will. So I'm going to put this data into an Excel spreadsheet, and it'll make a graph for me with linear regression. And that's what I want you to do on an upcoming group assignment. I want you to use Excel. So let me show you how to do that. You can even do this on the homework. So I got Excel open here. Now I could go through and type these, but sometimes when I'm really lucky, it will let me just copy and paste these over. So I'm just right now, Control C. So we had time and hours. I'm going to have to probably type these. The distance in miles. Then I'm just going to go right here and hit paste and see if it works. Ah, look at that, it did. That doesn't always work. I don't know what goes on, but sometimes I can copy and paste from like the My Open Math homework over here. If not, you literally just type them in. Make sure you put headings on there because we want those on our graphs though. Okay, now I can highlight both of these. And I'm going to go, make sure you write down these steps. And Microsoft is so weird. If you installed Microsoft Excel like the day after I did, it's possible that you have a slightly different version than me. And so the buttons may be in a different place for you. Like I'm on a Mac and you're probably on maybe like a Chromebook or something. So I guarantee you, if that's the case, your button's going to be in a slightly different place. You'll have to find it. You can do all this in Google Docs too, by the way. Google Docs will do all this too. So you may have to search around to find this stuff, but I'm going to go insert. And I want this button right here. I'm going to insert a scatter plot. And I'm going to pick this one right here. So there's my scatter plot. I can go in here if I go to add chart element, and on that upcoming group assignment, I want you to do this. I want you to create a nice, pretty spreadsheet. I'm going to put on the titles here. So let's see, this was time in hours. And then I'm going to add the vertical axis. Distance in miles. And I'm going to change this to be distance versus time. Okay, now we're going to add on to this. We're going to have Excel find that regression line for us. So I'm going to add chart element. Again, you might find this button in a different place in your version of Excel. So you may have to search around and find that. But I'm going to add a trend line and hit linear. See, it just added my line. Now I have to come back here after doing that and come back down here and go to more trend line options. So I'm here in add trend line, more options. I don't know what happened. Why didn't it give me more options? Oh, here it's over here now. So this popped up and I want to display the equation and I want to display R squared. And then I can grab that and move it around. Did you see what I did there? I just grabbed that box and moved it around. Hold on, these are different numbers. Okay, I was wondering why was it giving me different numbers? Because I'm doing a different version of the problem. These are different numbers, same problem, but different numbers than the ones I just typed into the calculator. If I'd used the same numbers, I would have gotten exactly the same equation. Now, this doesn't give us R. So I do have to do a little bit of extra work here. It won't give me R. It gives me instead R squared. So if I want the correlation coefficient R, I just have to take the square root of that guy. But now I have my regression line right there. There's my slope. There's my y coordinate of my y-intercept. I've got a nice pretty picture. I can now put this entire picture into a Word document. So if I open up Word or Google Docs or whatever, like again, you can do all this in Google Docs also. I can just highlight this graph here, make sure I've labeled everything nice and pretty, and just copy. I just hit Control C, go into Word, Control V, paste it over. So you're going to be doing that in your biology class, your chemistry class, maybe your physics class. You'll be asked to do linear regression. And like, I don't know, I just like this a lot better than doing it on the calculator because look, there's a nice pretty picture I can turn in. You'll be using this a lot. This is one of the main things from this course that you actually use in other courses. Okay, now we got this group assignment coming up that I want to talk about. This is the main reason I also had that extra Zoom meeting that you're going to have to watch, because a lot of people make this problem harder than it needs to be. So make sure you watch that other meeting, but I'm just going to say all this again. I'm going to say it quickly. You've got here the cost of postage stamps in dollars. These are in dollars. I know it should say that, but it doesn't. These are in dollars versus year. If I were to put these numbers in Excel and do a graph, I would get a graph that doesn't make any sense. I would get a y-intercept that wouldn't make any sense. Like, I don't know if it'll let me copy and paste from here. I'm going to try. Yeah, it's not going to. If you were to type all these in, like, let me show you. So like 1971 to 1973, and then whatever the numbers were, I'm making up my own numbers here, but maybe I'm put one more in 1975 and 0.13, whatever. If I were to highlight both of these columns, go insert, scatter plot, My graph is now starting at 1970, but this is supposed to be 0. That doesn't make any sense. Look, this jump right there, that's half a year. That's 6 months, 6 months, 6 months. This jump, however, goes from 19, we're 0. You got to have 0 showing on your graph. So the other way to do that would be, okay, draw this out. Have 0 here. So here's year 10, year 20, all the way up. It would be way over here, 1970. And all my data would be over here somewhere. So my y-intercept would be like way down here. I would get a prediction that in the year 0, 2,000 years ago, postage stamps cost -$40. That doesn't make any sense at all. The post office has only been around for a couple hundred years. There was no post office in the year 0. We don't want that. We have to have a 0 on our graph so that the y-intercept means something to us. We don't want our graph to be 2,000 years long. So what we're going to do is not use these numbers. You're going to start the clock at 1970. So you're going to write out, when you turn in this assignment, I want you to do this assignment in Word. Don't write this out on paper. First thing you're going to do is type out I'm trying to get out of there. Let X be years after 1970. Then make a little table here. Like I can just do insert table. So this would be year, this would be X, and this will be price in dollars. So that first year they gave me there, 1971, would correspond to how many years after 1970 is that? That's 1 year after 1970. And then this is 0.08, 0.08. And the next one was 1974. That's 4 years after 1970. This is a dime. 10 point, I'll be consistent, $0.10 and so forth. So do a whole table for this. You can do this in Excel and copying that over if you want. Then these are the numbers here that you're going to build your graph on. If you have numbers like 1975 anywhere in your graph, you're doing the whole thing wrong. You should have small numbers like this. And here we'll put a couple more in. 1975 was 5 years after 1970, and a postage stamp cost $0.13 then. Now we're 8 years after 1970, and that's 15 cents, 0.015. So these are the numbers. I can just copy and paste these. Not that. So years after 1970. And then I can insert graph here. And I'll get a graph that looks like this. Now, like if I were to have my scatter plot come in here, my linear regression, my line of best fit, that y-intercept is going to make sense. It's going to be like I can see right there. It's going to be about 7 cents, something like that. So now I can write a sentence like, the model predicts, well, what's x equals 0? X equals 0 is 1970. In the year 1970, a postage stamp cost blank. We're not making predictions about 2,000 years ago. So 0 needs to correspond with something. I mean, it doesn't have to be 1970, but that's what I think you should use. Okay, and of course, you're going to add your labels on. You're going to write up complete sentences to answer all of these questions. So, like, don't try to squeeze it all in here. You're just going to type all this up. And you're going to create a nice, pretty picture like this that you'll just copy and paste over into your Word document. Okay. And again, these are in dollars. Make sure these are not cents. I think I go on that whole rant in the other video. Don't do anything in cents. These are all in dollars. That's $0.15. I know, we all know that means 15 cents, but don't call that 0.15 cents because it's not. That's $0.15. Okay, make sure you've watched, like it says all that right here too. This is, out of all the group assignments all semester, this is the one students have the most trouble with. So that's why you're watching 2 different videos on it. Please watch the videos. All right, I'll shut up now. Stop the recording.